Section 4.7 is about inverse trigonometric functions. So we're first going to define what an inverse trig function is, and then we're going to evaluate the inverse trig functions. So recall, for a function in order to be an inverse, it must be 1 to 1. And then the way we've tested that out is it must pass the horizontal line test. I'm writing kind of large here, so I'm going to write a little over here. So it's going to pass the horizontal line test. Now what that means is if I were to draw a horizontal line test through sine, it's got to pass only one. Now it's this line here on this graph, it's going to cross the curve 3 times. So it fails. So instead of worrying about that, we're going to have to implement what we're going to call a domain restriction. So our domain restriction is only going to focus on a small part of this, well, technically infinitely large map. We're going to say it's negative pi over 2 is less than x is less than or equal to pi over 2. So negative pi over 2 less than or equal to x and less than or equal to positive pi over 2. So with that in mind, we're only focusing on from here to here. So that means if I were to take a horizontal line and anything in that domain restriction, it's going to pass the horizontal line test. So that part we can use for our inverse. Now, with this in mind, I'm actually going to zoom out a second. I'm going to have us, not zoom out, I'm going to have us look at 2 different windows. But I'm going to have us make a graph or make a chart of the sine function. So we're going to do y equals the sine of x. Now we're going to come up with some x values and plug those in, and we're going to get some y values out of that. So with this domain restriction, we're working between negative pi over 2 and positive pi over 2. So let's just start at negative pi over 2. So at negative pi over 2, so on the unit circle, that's down here. 3 pi over 2 and negative pi over 2 are the same thing. They're the coterminal angles. So the y value there, the sine value I should say, is negative 1. At negative pi over 4, I'm not going to do every value here, but at negative pi over 4, so again, that's coterminal with 7 pi over 4, we look at the sine, which is negative root 2 over 2. And let's see, another one, let's do negative pi over 6. So essentially we're rotating 30 degrees down, so we're down here. The sine there is negative 1/2. And let's do at 0. Well, the sine at 0 pi is 0. Then going in the positive direction, at positive pi over 6, our sine is positive 1/2. At positive pi over, oh, I miswrote something earlier. So that was supposed to be pi over 4, negative pi over 4 up top. My apologies. At positive pi over 4, we're at positive root 2 over 2. And at positive pi over 2, we're at a height of positive 1. So these are the points on the original sine function. For the inverse sine function, we're going to say y equals, and there's 2 different ways we're going to notate it. We got the inverse sine of x. So sine, it looks like it's being signed to the negative first. We're going to say that's the inverse sine. Also, commonly, you'll see it written as arc sine of x. So again, we're going to get some x values and y values. Now, thinking back to what we did with inverses in the past, we're just going to be flip-flopping the x values and the y values. So instead of negative pi over 2, negative 1, it's going to be negative 1, negative pi over 2. The second one, again, this is the one I made a mistake on, so make sure you correct it. It should say negative pi over 4 there. We're just going to flip-flop the x and the y, so we got negative root 2 over 2 and negative pi over 4. And then negative pi over 6, negative 1/2, flip-flop those, so we got negative 1/2, negative pi over 6. 0, 0, well that's not too bad. We got 1/2 pi over 6, root 2 over 2, pi over 4, and finally we have 1 pi over 2. Now we're going to make a rough sketch. I'm going to actually zoom back in on just the iPad notes now. We're going to make a rough sketch of what this graph would look like. So let's draw this. Now our x values are going to go from negative 1 to positive 1, so let's start with there. So negative 1 goes over here, positive 1 is over here. Now the other x values we have, we're not going to have all the most convenient, but we are going to have negative 1/2 and positive 1/2. We also have negative root 2 over 2 and positive root 2 over 2. Well, negative root 2 over 2 is a little bit over halfway. So if this is negative 1 over 2, we're going to say this is negative root 2 over 2. And so positive 1/2 is over here, and then we're going to make this positive root 2 over 2. So it's actually just a little beyond 1/2, so it's not quite halfway from 1/2 to 1, but pretty close. Then we're going to plot the y values. So the y values go from between negative pi over 2 and positive pi over 2. So I'm just going to make this our our positive pi over 2, and down here equivalent distance, we're going to make that negative pi over 2. Now the other distances, or the other y values that we have, are pi over 4. That's half of pi over 2, so we'll graph those. So that's pi over 4 and also negative pi over 4. We also have pi over 6, which is 1/3 of pi over 2. So we're going to approximate it as there and there. And again, this is not going to be perfect, and that's okay. So here's positive pi over 6. Here's negative pi over 6. And we also have the good old point 0, 0. So we're going to graph these, approximating them as best we can. So -1, negative pi over 2, we're going to say is right about there. Negative root 2 over 2, so over here, down at negative pi over 4. Negative 1/2, negative pi over 6, and then 0, 0. And then over here we got positive 1/2, positive pi over 6, positive root 2 over 2, positive pi, and 1 root 2, or sorry, pi over 2. I missed a bar on my fraction there. So this is not my best drawing. This is, again, freehanding it, not drawing it perfectly scaled, but it should kind of follow a smooth curve. This is not the best, but it's kind of like if you were to rotate it sideways. I can't really demonstrate that on here. But if you rotate it sideways and you were to keep this pattern going, it would just kind of like keep going on that sine curve, like the same thing over here. So I can't demonstrate that fully, but if I zoom out, you can kind of see how that pattern would keep going. But for what we're doing here, this is going to be good enough. So getting a little more specific, the definition of the inverse sine function. The inverse sine function is defined by y equals arc sine or inverse sine of x if and only if the sine of y equals x. And our x values are going to be between -1 and +1, so kind of using that table that we had up top. We could include other points in between there, but between -1 and +1. And the outputs are going to be between negative pi over 2 and positive pi over 2. So our y values are negative pi over 2 to positive pi over 2. The domain of y equals arc sine of x is between -1 and 1, as we just said, and the range is between negative pi over 2 and positive pi over 2. So again, we're really focusing on quadrants 1 and 2. Only quadrants 1 and 2. Sorry, not 1 and 2. Goodness gracious. 1 and 4. So only quadrants 1 and 4. Now I'm going to zoom back out because we're going to need the unit circle here. So let me shift this over here. So we're asked to find the possible exact value of the following things. So we're saying arc sine of -1/2. In other words, sine of what angle equals -1/2. So we're going to look on the unit circle, and I'm going to click on this. I'm going to zoom in a little bit because we're only looking at quadrants 1 and 4. So on the right side of the screen. So looking for where sine is equal to -1/2. Well, that's down here. Our y value, our sine value is -1/2. Now, you'll see it's the radian measure is at 11 pi over 6. But that kind of conflicts with what we're supposed to get here. It says our outputs can only be between negative pi over 2 and positive pi over 2. So what we're going to have to do instead is we're going to have to describe the negative version of that angle. So what negative angle is coterminal with 11 pi over 6? Well, taking a look at this size here, it seems to be the same size as positive pi over 6. So we're going to say the arc sine of -1/2 is negative pi over 6. It's as if we rotated downward in that direction. Trying the similar thing for sine, or the inverse sine, again, just a slightly different notation. They really mean the same thing, of root 3 over 2. So we're going to look at the unit circle again, find out where the positive, or where the sine is equal to root 3 over 2. And that's up here at pi over 3. So we're just going to say the inverse sine of root 3 over 2 is pi over 3. The last one on this one, inverse sine of 2. So we're plugging in x equals 2. Well, that doesn't work. We're going to say there's no solution. That's kind of what that symbol means. So we're going to say no solution, because if you go back and look at our notes here, in our notes, our x values, what we're plugging in, have to be between -1 and +1. Also thinking about the unit circle, we never get an x value larger than -1, or sorry, larger than 1 or less than -1. So it's not in our domain. We're going to say x equals 2, not in our domain. Or not in, I should say, the domain.